Hello everyone. In this video, we're going to discuss how to solve the candy problem. So there are n children standing in a line and each child has a rating. So we have the ratings array. We are given infinite number of candies and we should distribute them to these children such that we satisfy the following requirements. Each child must have at least one candy, and the children that have higher rating must get more candies than their neighbors. We should return the minimum number of candies that we need to distribute, such that we satisfy the conditions above. So let's go to the canvas and discuss the examples. In the first example, we have this ratings array. So each rating represents a child. So this is the rating of the first child, this is the rating of the second, and this is the rating of the third. So we know that each child must have at least one candy. So let's try to give each child one candy. Okay, now let's see if all the neighbors are satisfying the conditions. Remember that the conditions are two. Each child must have at least one candy. All of the children satisfy it. And the second requirement is that the child with higher rating must get more candies than its neighbors. So what does it mean to be neighbors? First of all, each two numbers which are directly beside each other are called neighbors. So we have these two are neighbors and also these two are neighbors. But this one and this one are not neighbors. So we do not need to satisfy any condition between this number and this number. So let's satisfy the conditions between each two neighbors. So first of all, let's take these two neighbors. This one has a higher rating than this one, so it must take more candies. This one has one candy, so this one must have two candies. This is the minimum number of candies. We can say it should be 3, but because we should distribute the minimum number of candies, so we only increment it by 1. So now the condition is satisfied between these two neighbors. Let's go to the other two neighbors, which are this one and this one. So this neighbor or this child has higher rating than this child, so it must have more number of candies. This one has one candy, so this one should have at least two candies. So the condition is now satisfied between these two children as well. So now all the conditions are satisfied for this example, and the answer will be simply the sum of the candies array, which will be equal to 5. Let's go to the second example. In the second example, let's give each children one candy, and let's satisfy the conditions between each two neighbors. So let's take these two neighbors. This one has a higher rating, so it must take more candies. So let's give it 2, because this one has 1. Let's see the other two neighbors. So these two neighbors have equal ratings, so there are no conditions other than that each child should get at least one candy, which is already satisfied because this one has 1 and this one has 2. So we are good to go. So the answer in this case, because we are done, the answer is in this case will be equal to the sum of the candies array, which will be again equal to 5. So let's see the third example, which is an example that I came up with in order to try to see what is the pattern that we are following to distribute the candies to the children so that we can implement it. In this third example, let's first of all say that we will give each child at least one candy because this is one of the requirements. So I will not fill the candies array. So let's suppose that the candy right here, this is an array. I will not fill it with any numbers, but let's suppose that it will be pre-filled with numbers equal to 1. So let's suppose that all of the children will have initially one candy. Okay? But I will not fill it right now, and you will see why. Let's take the first child. So what are its neighbors? It's this one right here, which is nothing because it's the first child, and it's this one right here. So is it larger than this neighbor? No, there is no neighbor right here. Is it larger than this neighbor? No. So it will only take one candy, which is the minimum number of candies. Okay. let's say that, let's take the next child. So as if we are iterating over the array. So I is the iterator and I is now here. Let's check for this number. Let's call this number Ri. So this will be Ri. And the number of candies that it will have, it will be equal to Ci. So let's compare Ri with the previous rating. So its rating of its first neighbor. Is it larger than it? Yes, 2 is larger than 1. So this number right here, at least it must take 2 candies. So Ci must be at least equal to 2. Is it larger than this child? No, so we do not do anything. Let's go to the next number. So let's put I right here. So this is now Ri, and this is now Ci. And let's compare Ri to the previous rating. So Ri is a 3, which is larger than 2. So it must have at least, Ci must be at least equal to Ci minus 1 plus 1 candy. So it will be equal to 3. So at least this child right here, at least it must take 3 candies. And what about the relation between Ri and Ri plus 1, where this is Ri plus 1? They are equal, so we do not need to do anything in this regard. So let's advance I by 1. So I is now here. What about the relation between this and the previous neighbor, between this one and its previous neighbor? They are equal, so we do not do anything. Remember that we assumed that the number right here is currently equal to 1. We assumed that each element at least has 1 candy. What about the relation between this number and its next neighbor? It's less than the next neighbor. The rating right here is less than the rating of the next neighbor, so we do not increment its candies. So it will have only 1 candy. Let's advance I. So I is now here. Let's check its relation with the previous neighbor. So Ri is larger than Ri minus 1. This is Ri minus 1, which is equal to 3. And this is Ri, which is equal to 4. So the rating of the current child, Ri, is larger than the rating of the previous child, Ri minus 1. So the candies of this child must be larger than the candies of the previous child. So the candies of this child, which is here, must be equal to at least Ci minus 1, which is the candies of the previous child, plus 1. So at least it must be equal to 2. And regarding the relation between Ri and the next neighbor, they are equal. Ri and Ri plus 1 are equal. So this is Ri plus 1. It's equal to 4. It's this one. So they are equal. So we do not need to change this number because of this relation. So let's advance I. Let me clear this up. So I is now here. You can start to see the pattern that is emerging. For each number, Ri, before it we have Ri minus 1, and after it we have Ri plus 1. Before it, Ri minus 1 has candies equal to Ci minus 1, and after it, number of candies is equal to Ci plus 1, and we are trying to assign its number of candies, Ci. So for each iteration, we are trying to find what is the Ci that we should put. So if you have followed with me the pattern, for each number we are saying if Ri is larger than Ri minus 1, so if this current rating is larger than the rating of the previous child, then Ci will be equal to the previous rating plus 1. Why not a plus 2 or plus 3? Because we need to distribute the minimum number of candies. And we are saying else if Ri is larger than Ri plus 1, so if the current rating is larger than the rating of the next child, we will see now what we will put, and else, which means if this condition is false and this condition is false, which means, in other words, if Ri is less than or equal Ri minus 1 and Ri less than or equal Ri plus 1. In this case, we will see what we will do. So let's continue our iterations and see what we are going to do. So for example, I is now here at this 4. So first of all, according to the algorithm that we have came up with until now, this one right here, let's check Ri, the relation between Ri and Ri minus 1. So this is Ri and this is Ri minus 1. So if Ri is larger than Ri minus 1, no, this is not the case. Is Ri larger than the next number, which is Ri plus 1, which is this one? And no, this is not the case. They are equal. So then we are in this case right here. Ri is less than or equal, in this case it's equal to Ri minus 1, and Ri is less than or equal to Ri plus 1, in this case it's equal to Ri plus 1. So what should we do in this case? Remember that we assumed that each child has already been given one candy. So in this case, this child will have one candy and we do not do anything. So we only say that give this child one candy only. Okay? Let's go to the next child. So now the iterator is here. So let's check our conditions. Is Ri, let's check this condition first. Let's check this condition. So is Ri larger than the previous one? No. Is it larger than the next one, Ri plus 1, which is here, this condition? Yes. So what should we do? We should say that Ci is equal Ci plus 1 plus 1. What does this mean? This means that this Ci right here should be equal to the number of candies of this number plus 1. We assumed that each number has a number of candies of 1. So this number right here, we assumed that it has a one candy. Until now, at this point in time, this number right here, this child right here has one candy. So this child, which is Ci, it should have 2 candies at least. So this is what we should do in this condition. Let's continue. So I is now here. Let me clear this up, and this as well, and this, and this. So I is now here. Let's compare Ri to the previous rating. Ri, is it larger than Ri minus 1? No, it's less than. Is it larger than Ri plus 1? Is this condition true? No, they are equal. So the last condition is true. So what should we do? We should give it only one candy, because it's not larger than any of its neighbors, and it should at least have one candy. So we give it the minimum number of candies. Let's advance I. So I is now here. Let's check our conditions. Is this rating right here larger than this one? No. Let's check the second condition. Is this rating here larger than this rating? Yes. So this rating Ri, it should be larger than Ri plus 1. And remember that we assumed that Ri plus 1 is equal to 1, because we assumed that all the numbers that have not been set yet have one candy. So Ri should be equal to 2, which is Ri plus 1 plus 1 candy. Okay? Let me clear this up and let's advance I to the next position. So I is now here. Let's check our conditions. This is Ri. The 2 is the Ri. So is it larger than this one? No. So the first condition is not true. Let me clear this. Is it larger than the next neighbor? Yes. So this condition is true. So this is Ci and this is Ci plus 1. So we should only apply what we should do in the condition, which is this statement. So we should say that Ci is equal Ci plus 1 plus 1. What is Ci plus 1? Because we have not set it yet, we have assumed that it will be equal to 1. So this number right here, it will be equal to 2, which is 1 plus 1. So let me clear this up and advance I by 1 position. So I is now at this position. Let's check the conditions. Is this rating right here larger than this one? No. So this first check is not true. Okay. Is it larger than this one? There is no number to its right. So this condition is not true. So we come to the else, which is the true condition in this case. So we say that Ci is equal to 1. So Ci will be 1. And now if we advance I, we will go outside of the bounds of the array. So we stop our first iteration. Why I am saying first iteration? Because in this iteration, what have we achieved? We are sure now that for any number that you take, let me write it here, for any number at any position I that you take, we are sure that the conditions that we should satisfy between Ri and Ri minus 1, we are sure that they are satisfied. Why we are sure that they are satisfied? Because we have put this condition as the first condition. So if Ri is larger than Ri minus 1, then Ci is equal Ci minus 1 plus 1. So we are sure that we have satisfied this condition right here between Ri and Ri minus 1. Well, what about the condition between Ri and Ri plus 1? Are we sure that it's satisfied for any position in the array? Let's look at the array. Let's look at these two numbers right here. So let's say that this is Ri, this is I right here, and this is Ri plus 1, right? Let's look at Ci and Ci plus 1. So we have Ri is larger than Ri plus 1. So the rating here is larger than the rating here. But we have Ci is equal to Ci plus 1. Ci is equal to Ci plus 1, which is a violation of the rules. Because this child has higher rating than this child, but they have equal candies, which is a violation of the rules. So we are not sure that for any position I, we are not sure about this relation between this child and this child. So what should we do in this case? Let's try to make another loop. Let me clear this a little bit. So let's try to make another loop in this direction. Remember, the first loop was in this direction. So this is pass 1. Let's try to make another pass of the array in this direction and try to fix for each iteration, fix the relation between Ri and Ri plus 1. And we should also prove that while we are fixing the relation between Ri and Ri plus 1, we should prove that we do not break the relation between Ri and Ri minus 1. And we will prove it right now. So let's begin our second pass. In our second pass, we should also put a set of conditions. So I will call these conditions the conditions of pass 1, and I will put here the conditions of pass 2, or the checks. So in the second pass, I will start at the last index, which is here. So this is Ri. Remember that we are trying to fix the relation between at each position, at each index I, we are trying to fix the relation between Ri and Ri plus 1. So between the current number and the next number. So when I is here at the last index, we do not have Ri plus 1 because there is no number to its right. So we don't do anything. Let's come here. So I is now here. This is Ri and this is Ri plus 1. Let's see. So Ri has higher rating than Ri plus 1, and the number of candies here is larger than the number of candies here. So we are all good to go. So we don't do anything. Let's move I to the next index, which is here. And let's try to see if we have a broken relationship between Ri, which is here, and Ri plus 1, which is here. So we have Ri larger than Ri plus 1. So if Ri larger than Ri plus 1, and we have the candies equal. So how do we know that the condition is broken? If Ri is larger than Ri plus 1 and the number of candies at Ci is less than or equal number of candies at Ci plus 1, so in this case we have a broken condition. So what should we do? We should increase the number of candies at Ri, which is here. By how much we should increase it? At least we should increase it by 1 candy more than Ci plus 1. So the child with higher rating should have the least minimum number of candies, which is at least 1 candy more than the child with the lower rating. So how do we know this number? let's say that we call it increment. So the increment will be equal, if you see this is larger than this, so we can say ci plus 1 minus ci plus 1. So for example, right here, this is ci plus 1 and this is ci. So ci must be, we must add to ci the increment number. So for example, right here, we must add to this ci the increment number, which is 2, this 2, minus this 2, which is 0, plus 1. So we must add 1 to this 2 right here. So this 2 becomes a 3. And if you look at it right now, we have this is Ri, higher rating than this child, and the candies are more than the candies by the minimum amount. Okay, but let's also remember to check if we have broken this red relationship between Ri and Ri minus 1, which is here. Have we broken it? It's impossible that we break it. Why? Because, let me put it here. In the first pass, we made sure that Ri is, that the relation between Ri and Ri minus 1 is satisfied, which means that if Ri is larger than Ri minus 1, then the candies Ci is larger than the candies Ci minus 1. And in this second pass, we have made sure that if Ri is larger than Ri plus 1, then Ci is larger than Ci plus 1. What we have done, this is what we have done in the first pass. This is what we have done in the second pass. In the second pass, we only increased Ci, as you can see here. We can only increase Ci. We do not decrease it. So this relationship will always hold. It will never break. So this second pass comes to make sure that what we have not satisfied in the first pass will be satisfied now. In other words, in the first pass, we are guaranteeing the relation between Ri and the previous number and the previous rating. And in the second pass, we are guaranteeing the relationship, or we are satisfying the relationship between Ri and the next rating. So let's continue our algorithm and make sure that it will work. So for this position I, we have already satisfied the conditions. Let's move I. So I is now here. And do we have the condition satisfied between these two numbers? Well, they have equal ratings. So this is Ri and this is Ri plus 1. They have equal ratings. So this condition, Ri strictly larger than Ri plus 1, it is not true. So we do not do anything. Let's go to the previous index. So I is here. Well, now Ri is larger than Ri plus 1. Okay, but the number of candies here and here, it's satisfied because this one has higher rating than this one, and it has more candies than this one. So we are good to go. Let's make I here. Let me clear this up a little bit. So I is now here and this is Ri. So Ri, is it larger than Ri plus 1? No. So we do not do anything. Let's go here. So I is now here. So we are checking Ri and Ri plus 1. They are equal. No one is larger than the other. So we do not do anything. So let's move I. So I is now here. Ri is here and Ri plus 1 is here. Ri is not larger than Ri plus 1, so this condition right here is not satisfied. So we do not do anything. And here we have I, so it's equal to the next neighbor. So Ri is equal to Ri plus 1, so we do not do anything. So we just move I. Same here, same for this I, and same for this I, and now we are done. And let's look at the final array that we have got. So if you look at the array, take any number. For example, take this 4. How many candies it should take? It's equal to this, this rating is equal to this rating, and this rating is equal to this rating, so it should take the minimum number of candies, which is 1. Take, for example, let me clear this up. For example, take this 4. So it has higher rating than this 3, and it has higher candies. It has equal rating to this 4, so we do not need to do anything in this regard. So it's satisfied as well. Take, for example, this 2. So it has higher rating than this one, and it has higher number of candies. It has lower rating than 3, so we do not need to do anything. For example, this 3, it has a higher rating than this 2, so it has a higher number of candies, and for this relationship, it is equal to 3, so we do not do anything. So as you can see, this algorithm has a time complexity O of n, because it passes through the array 2 times and it has no nested loops. And the space complexity is also O of n, because we are using an extra array to store the number of candies that each child has got until now. Because we need to use an extra array, because we are doing 2 passes of the array, so we need to memorize the results. So let's write the algorithm and then submit it. So I will define the iterator. It will initially start at 0, and I will define a variable to track the candies, so I will call it candy count, and initially it will be equal to 0. And I will define the candies array, so it will be called candies, and I will define it to have the same size of the ratings array, so it will be the same size, so it will be rating size times size of int, so it will be also an integer array. And I think these are the variables that we will need. So let's do the first pass, where we will make sure that the condition between Ri and Ri minus 1 are satisfied for all i's. So we will start from I equal to 0, so while I is less than rating size. In each iteration, what should we do? We should do the checks that we already wrote on the canvas. Right here. So these are the checks that we should do in the first loop. So for every I, if Ri is larger than Ri minus 1, then we set the number of candies at the position I to this one, and we do the other 2 checks. So the first check is if Ri is larger than Ri minus 1. So first of all, if I is larger than 0, so that we do not go out of the bounds of the array, and ratings of I is larger than ratings of I minus 1, then in this case, what should we do? As you can see here, we should say that the candies of I equal candies of the previous number plus 1. So we say that candies of I is equal to the candies of I minus 1 plus 1. And let's also say that candy count plus equal, what did we do here? We gave this child this number of candies, so let's add it to the total candies. So we add it to the total candies. And what is the second check? So here is the second check. So if Ri is larger than Ri plus 1, we should say that Ci equals Ci plus 1 plus 1. So else if, I don't even think that the else is needed, or rather not, yes, it's needed, because we do not want to override this action. So else if ratings of I, so if this condition is not true, If ratings of I here, ratings of I is not larger than the previous number. So let's do one more check. Let's see if ratings of I is larger than the ratings of the next number of I plus 1. In this case, we should give candies of I, so we should give the current child equal to 2. Why is equal to 2? Because let me remind you, let's go to the canvas. In the first pass, let's say that we were standing, for example, at any number. Let's say we were standing here. Then all of these numbers, we have not set their candies yet. So we cannot say that Ci is equal to Ci plus 1 plus 1. But we already know that all these numbers right here, we already assumed when we are standing here at this I, we already assumed that all these numbers right here have been given in this pass, which is pass 1, they have been given 1 candy. So this number right here, Ci plus 1 plus 1, it will always be 2 in this first pass. So we can do it right here. We can say candies of I equal to 2. And the last check that we are going to do is, in all other cases, we should give 1 candy to the child. So else we will say candies of I is equal to 1. And let's also not forget to increase the candies count in each time. So here candies plus equal to 2, and here candy count plus is equal to 1. Now let's make the pass 2 where we make sure that conditions between Ri and Ri plus 1 are satisfied for all i's. So now let's reset I. It should be, and let's also not forget to increment I. So let's make I is equal to the last index, ratings size. Let me make it equal to the index before the last index, because the last index already does not have any number to its right. And in this pass, we are comparing each number with the number to its right. So it's redundant to make it -1. It should be -2. So what should we do in the second pass? Let's go to the canvas. So we should do this condition. So if ratings of I larger than Ri plus 1, so let's say while what? While I is larger than or equal to 0, because we are going backward. So if ratings of I is larger than the next rating, and if the candies at the current index are less than or equal the candies at the next index. So in this case, as you can see right here, we already put this condition. So we should calculate the increment. So in increment, it's equal to candies of I plus 1 minus candies of I plus 1. And we should increment the candies. So candies of I plus equal to increment. And we do not want to forget to increment the candy count. So candy count plus equal to increment. And we should decrease I. Finally, let's, because we are using C, let's free the memory, the extra memory that we have allocated. We allocated memory for candies. So let's free candies and return the candy count. Let's try to submit it to submit the initial test cases. And we have something wrong. Okay, here we should also check if I is less than rating size minus 1. Because in this case, I max will be equal to rating size minus 2, and then I max plus 1 is equal to the last index, which will be equal rating size minus 1, and we are safe. Because this error means that we applied this check to the when I was equal to n minus 1, where n is the size of the array. So I plus 1 was equal to n, which is not a valid index. So we cannot write in this case ratings of I plus 1. This will be false, which means it will throw an error. So let's try submit it again. And let's try to submit our answer, and hopefully it passes from the first time. And as you can see, it passes and beats the runtime as 100%. So that's it for this video. Thank you very much. If you like the content, like and share and subscribe, and let me know in the comments what you want to see, which problem to solve next. Thank you very much.